Hey, you're doing you. Okay. Number today, which is 4-6. Okay. Today is other trig functions. Meaning the rest of the 6.
Do we have to do the tangent?
Yes. Where do you guys want me to start? We might as well start with last time because that was basically what secant and cosecant is going to be. You guys want me to start with the parent function and explain why it looks the way it does?
Yes.
Okay, should we start there? Okay, so we're going to start with, once again, y equals cosecant of x. Now, if you'll understand this, what is cosecant? If I told you the sine of an angle is a half, what is going to be the cosecant of that angle? It's going to be the reciprocal, correct? Okay, so therefore, I'm going to graph sine first. Once again, still using the nice values. So 0, pi half. What was the sine of pi half? It was 1. Pi was 0. 3 pi halves was -1. And then we have 2 pi. And it came back to 0. Now, here is in black the sine graph. This is not the cosecant graph. Okay, like I just said, at the angle, basically it's just the reciprocal of the y value that I got, right? Does that make sense? Am I talking to bricks out here, or are we okay? What is the reciprocal of 0? Undefined. So hence an asymptote. Cosecant does not work at 0. It's undefined. Okay? Once again, it's going to be undefined at 0. Well, in this case, I just like to say anytime I hit my midline, because then that works for cosecant and secant. Does that make sense? Okay, here we go. What is the sine of pi halves? We already noticed it is 1. What's the reciprocal of 1? 1. What's the reciprocal of, it was at pi 6, that gives us a half. What's the reciprocal of half? 2, so it's going to come up here. Now, what's the reciprocal of a very small number? A very large number, so hence it approaches the asymptote. Right? Notice it's going to be a reciprocal coming up, and then the reciprocal of a very small number is a very large number. So then we go here, do the same thing. What's the reciprocal of -1? It's still -1, right? The reciprocal of this small number is a very large negative number, meaning, I don't want to say it like number-wise, right? Like expanding out a number. Are you alphabetizing those for me?
Yes.
Hip, hip, hooray! Super readers are reading today. That's what I think of. All right. Right there, guys, that's cosecant. Does it really have an amplitude? Kind of the amplitude is going to be the value that's kind of going to be what we call like our max and our min point, right? Does that make sense? Meaning this has a low point, so that is a localized minimum, we could call it. I mean, that's the lowest I'll ever be, right? This will be the highest it'll ever be in this section, is hitting that height. Are you guys with me? Huh? It really doesn't have an amplitude, but we use sine's amplitude to find these, basically the points of the home. See what I'm saying? Does that make sense? What's this period? Still 2 pi, because once again, what's the definition of period? When you do your extreme highs, come back to your extreme lows, and then come back to exactly where we started, and that would still be 2 pi. Everybody there with me? Any questions with that? Do you get the idea of then secant? Do I need to do cosine? Anytime we hit the midline, that's where it's going to be an asymptote. Does that make sense? So can I give you one straight up hard? Like we did on... No problem. Which one?
The one with the
Okay, anytime, notice anytime sine hit the midline, that is where my asymptote is. You might want to have that in your notes. That's the two things that happen in your notes. Thanks for the patience. Hi, Tossie. Now, why does it look like these? Those are your asymptotes. Does that make sense? These lines right here, because on the graph, it's got to go from an extreme high down to an extreme low. The only way to get there is through a line. So they're basically doing a line. Make sense? It's an asymptote. Or even a cosine. You guys ready? Should we do it again? Okay, so this is why it's exactly the same thing as what we did yesterday. So if I said, okay, y equals -4 of cosine, we'll make it nice today. 3x plus 1, something like that. But instead of cosine, excuse me, I don't want cosine. Obviously, we're not doing cosine today. We are doing secant, right? But the way I would do this is graph it exactly the same way as cosine. And then a little bit of adjustments afterwards. Amber, are you okay? I got a blanket over there. No, just don't. It might have the measles.
Yeah, no.
Breckabastian. She asked if she could keep a blanket in. Message. Hey!
How's it going?
Do I get a sharpener?
I'll have the sharpener and shirts.
I get both! We're graphing. I start always where? Midline. What is the midline? 1. Oh! Now people eat chia seeds instead of making a plan out.
I do. Every day.
Supposedly healthy.
What?
Really?
Supposedly.
Chia seeds?
They are.
Where do you buy that? What seeds?
They're not.
Anyway, oh, hey.
Like chia?
Shwin. Okay, what is my amplitude?
4.
So therefore, I wait for my midline. I go 1, 2, 3, 4. So the highest, well, technically in a cosine graph, the highest will be as 5. 1, 2, 3, 4. The lowest will be as -3. Correct? What are my normal increments of cosine? 0, pi halves, pi, 3 pi halves, and 2 pi. What am I going to do to every single one of those? Multiply it by a third! Way to go, Hank! So I get 0, pi 6, pi thirds, pi halves. In other words, we're going in increments of 30 degrees. And 2 pi thirds. Yeah. Okay. So I got 0, pi 6. Notice all my graphs look the same. If you really notice, right? What's different? My increments. Correct?
Draw a graph and make the axis around it.
Basically, that's what you could do. Pi thirds, pi halves, 2 pi thirds. Anybody got a question? So, what I'm going to graph now is cosine. Not secant yet, but cosine. Very good. Okay, here we go. Here is cosine. I'm still going to keep it in black, actually. You know, cosine starts on our amplitude or our midline. Amplitude, are we having a high amplitude or a low amplitude?
Low.
Low, Betsy. Low. That's low. That was funny. No?
Very
No.
low.
Thanks for caring. Okay, there's our cosine graph. Is that what I wanted to graph though?
No.
So then, I come in here, I'm going to do this ugly orange, and I understand. Anytime I touch the midline, what does that become? Becomes an asymptote. I can understand the idea where it's at. It's on those places I hit the midline. Cheers. Now we go off the hump. That's really my instructions to you guys. Do your asymptotes. Go off the hump. So is this guy going to go that way or this way? because we want to approach the asymptote. Isn't always our goal is to approach asymptotes when we did the rational ones? You guys remember when we did that? We approached asymptotes, didn't we? That's our graph. That's all you do. Is that anything different than what we did last time, basically? Well, yes, it is. But is it too much? Hi!
Hey, you still on our dance team?
Well, I said I was in. So at 3 pi fourths, what is the tangent of there? Remember over there, it's negative root 2 over 2, comma root 2 over 2. It's going to be negative 1. So notice once again, you have to approach it. Then at pi, what do we get? 0. At 5 pi fourths, your tangent in quadrant 3 going to be positive, right? So it's going to be 1. And then notice at 3 pi halves, that's negative 1, 0, so that's an asymptote. So look, you're like, wow.
It's like a lone.
Whoa, whoa.
My pencil broke again.
That's why you use a pen.
No.
Somebody's like wearing math class. I hated when my teachers made me use pencils. I hate things.
I don't like pencils because they're not dark enough. You can't read them.
Oh,
They break bigger. They make your letters bigger.
And we're stuff on surface.
I was a mechanical pencil freak, but I had to have mechanical.
I really like mechanical pencils.
No, I'm just saying, if I was, I'm not a pen. Hey! What's its period?
Right, like a sumo wrestler.
It is not 2 pi. Notice I didn't get to 2 pi. My period's already there.
I think it's so.
Let's say it all to your head. Everybody think about it really quick. I'm going to push pause. I want you to think. Period. What do you got? It is. You said pi as well. Why is it pi? Well, look at this point. We're starting here. We go to our extreme highs, extreme lows. Notice, look at this guy. Just look in between pi halves and 3 pi halves. What's the distance in between there? Pi. Notice extreme lows,
Extreme high.
extreme highs, and then notice I come back down to extreme lows again.
Why isn't pi an asymptote?
Asymptote, no, because look at the point. What's the coordinate on our unit circle at pi? Negative 1, 0, correct? What is tangent on a coordinate? Y over x. What's 0 over negative 1? And 2 pi would also be at 0 as well. Okay? Really, all that does is, if I put a number there, what's it going to make it do? Instead of having it more like this, it just makes it steeper. Does that make sense? So the amplitude there, but is it really there? It just, what does it do? It makes it a vertical stretch. Okay? Is everybody with me on that? Yes, ma'am.
With the tangent and secant and cosine, all that stuff, I don't know what that's having to do with any of this. Like, I'm not catching it. Like, I don't know what.
This-
Oh, it's like a unit circle.
Okay, maybe I just lost what your question was.
How are you graphing it with?
Where did I get tangent? Okay, so what this is all it is me using values on the unit circle. Give me the first value on the unit circle, 0. Look at it, Hirsch, really quick.
It helps trust me.
When I'm looking at 0, what is the tangent of 0? Well, 0, I go use my, if you'll recall, is y over x at that coordinate. What's the y value?
0.
What's the x value? So 0 over 1 is 0. Then I go to pi fourths. What's the coordinate?
Square root
2
over 2.
square root 2 over 2. So therefore, when I do y over x, I get 1. As I get closer and closer, like I did here, pi thirds, I got root 3. Because if you recall, root 3 over 2 over a half came out to be root 3. You know what I'm saying? And then at here, at pi halves, look at pi halves, you got 0, 1. So when I do y over x, I get undefined, because that's 1 over 0. That's all I'm doing.
Okay, so like with cosine, then we use the cosine.
Cosine would be the x value on your unit circle. Does that answer your question?
Yeah.
Okay, thank you for, I was like lost for a little bit, but you just said it. Thank you. Here's tangent, guys. Okay? Now, obviously, we do the same things. We move it, we stretch it, it's the same ideas, right? The thing that I want you to think about, though, is what about cotangent? So really quickly, here's a little sketch. Once again, this is at pi halves. This is at 3 pi halves. Sketch really quick. and this is pi, and it looks like this, correct? Everybody there with me? What would cotangent look like then? How do you mean reverse? So where would the asymptote be? Anytime tangent is 0, because what's the reciprocal of 0? What's the reciprocal of 0? Undefined. The reciprocal of 0 is undefined. So notice I'm at 0, so therefore in cotangent, I'm undefined here. By the way, this is cotangent of x. Or you could even think of the values. Look on the unit circle. Cotangent is the x value over the y value. So if I went to 0, it would be 1 over 0. Does that make sense? Okay. So if it's an asymptote, what's the reciprocal of an asymptote? 0. What's the reciprocal of 0 again? Undefined, so therefore an asymptote, correct? And then I'm not going any further, because that gives me a whole cycle, actually. What's the reciprocal, because this was technically pi force, I was at 1, right? What's the reciprocal of 1? Negative 1? What's the reciprocal of 1? You guys understand what reciprocal means?
1.
You flip it, right? So it's just 1. And notice what's the reciprocal of negative 1? Negative 1. There you go.
So they're all the opposite.
Dampen, what do you mean dampen? No, like the ones that involve multiple variables?
Yeah.
No.
They're from trigonometric graph.
I've never used one of those until I got to calculus.
Use them like what?
Like we use them for doing just a derivative or something. They're just restrictions. They have multiple things. Anyway, what's its period? Still pi. We did one complete cycle in pi, right? Because notice this is technically right here. This is quadrant 1. Notice tangent's positive. Quadrant 2, tangent's negative. What about third quadrant? What would that be? Because in all students take calculus, the third quadrant's positive, hence it'll come down like that again. Does that make sense? Yes, no?
I'll get it.
Good? Yes?
So are cotangent and negative tangent the same?
No, sir. Maybe. No. Because all negative tangent would do, like, for example, negative tangent would be in my blue. Okay. So negative tangent would be like that. And notice it's not going through the same point. Now you could say negative tangent and cotangent are shifts of each other. Does that make sense what I'm saying? You could say negative tangent of x is equal to cotangent of x minus pi half. You could say that. You know what I mean?
Yeah.
But no, okay. They'll have a number there, but if I even ask you, still put the number. But what that does is, remember, just like if I had x squared, what does 3x squared do? Still the shape, just stretches it, right? You get what I'm saying? Because really, what's the amplitude? The distance away from the midline. Well, we still have a midline, but how high does it go? Infinite, negative. So it's kind of like, you know what I mean? So if there is a number, write just the number in front. I don't think there will be, but you get the idea. Okay. All right, guys, I think I'm good. So, this one, I really don't think you need a graph, but I'm going to, no, I don't think you need a graph. Well, like it's asking this. It says, where does tangent of x equal 1? It says, please find the values between negative 2 pi and 2 pi. How do you do that? How do you find the values of x that make that work? That's not even, to me, a graphing question. That's a unit circle question. Because where does it equal 1? Where does tangent equal 1? We're at the pi fourths and 5 pi fourths. We're in quadrant 1 and quadrant 3, right?
Yeah.
Does that make sense? Now, what is this as a coterminal angle that's negative? Negative 3 pi fourths. What's this? Negative 7 pi fourths. Those are the 4 spots. Well, because all it's saying is you have your unit circle that looks like this, right? So they want you to go from 0 to 2 pi and tell me every place it equals 1. It equals 1 here and 1 here. Does that make sense? And then now we got to go backwards, so therefore now they want to go from 0 to negative 2 pi. Well, what's this angle? Well, this is negative 3 pi fourths and negative 7 pi fourths. So you just find it out where it equals 1, and then basically use its period. What's its period? For tangent is pi, so I just subtract pi and subtract pi anyway. Does that make sense? A couple times, that'll get you there. Okay? Everybody with me?
Yeah.
Your homework's a little bit simpler today. Not as much. You are going to do I like that. That's a good question. It is, sir. So page 339. I'm trying to figure out if I want blue or I want that one. Good heck. I wrote odd.
Oh, no, I couldn't read it.
Oh, I'm like, I thought I did quite well.
That's it?
I'm glad you still played drunk.
What?
And would you like